Hello to all. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss sugar in watermelon and its colors. Sugar in watermelon and its colors. We have eaten many times watermelon. Now we should know sugars present in watermelon and why its color is pink, red, orange and other colors are also there. It is found in other colors also. That I am going to discuss. In a mature watermelon, sucrose and glucose concentration range from 20 to 40%, while fructose concentration is approximately 30 to 50%. Means in watermelon, sucrose and glucose, sucrose common sugar, and fructose already I have discussed. Its sweetness is more than sucrose and glucose. Then in watermelon, sucrose and glucose concentration range from 20 to 40%, while fructose, which is more sweeter than sucrose and glucose, or you can tell highest in common sugars, it is the highest. Then fructose concentration is approximately 30 to 50%. Watermelon flesh is 91% water by weight and is a rich source of bioavailable compounds including lycopene and other carotenoids, vitamin A and vitamin C, and the non-essential amino acid citrulline, and is about 6% sugar by weight. And what is the ratio of glucose and fructose? Then fructose and glucose ratio is 1:0.55. 0.5 also you can tell, but exact is 1:0.55. This is the ratio of fructose and glucose present in watermelon. Means glucose, fructose is found in more and glucose is found in less quantity. Watermelon typically has a GI of 72. Now we'll ask what is a GI? Then GI means glycemic index. Glycemic index, GI. Glycemic index is a rating system for foods containing carbohydrates. It shows how quickly each food affect your blood sugar level. Blood sugar level means glucose level. When that food is eaten on its own. Glycemic index is a rating system for foods containing carbohydrate. It shows how quickly each food affect your blood sugar level, means glucose level, when that food is eaten on its own. Now here that there's less than 55. First to understand that for this watermelon, its GI is 72. Watermelon typically has GI of 72. Watermelon has a low glucose level, and like all fruits, it can be eaten in moderation as a part of balanced meal. A GI of 55 or less is considered as low. Actually 72 is coming in the medium, moderate, 72. But less than 55 is considered as low. A GI between 55 and 69 is generally considered medium. Then here in watermelon, it's a 72. You can tell in medium, little more than medium. Okay, 55, between 55 and 69 or up to 69, it is considered as medium. Watermelon is safe for people with diabetes to eat in moderation, in moderate quantity, not in more quantity. The cause of this coloration, what is actually a reason, cause for its color? You might have seen that watermelon color is very attractive, sometimes orange, sometimes red. Then what is its chemical reason? Why it looks so? Then the cause of this coloration is a chemical called lycopene. Lycopene is a carotenoid pigment like beta carotene, the compound that gives carrot their orange color. Carrot you might have seen, not 100% you have eaten. Then there carotene, beta carotene is found. Then the cause of this coloration is a chemical called lycopene. Lycopene is a carotenoid pigment. Only from that word carrot came. Carrot word came from carotenoid pigment. And here beta carotene is found. And this beta carotene is found in carrot. And due to this, its color is orange color. Now, this watermelon, actually it is found in different color. It is found in red, pink, orange, yellow, green or white. But red or pink is most common. Generally, watermelon is found in red and pink color. Sometimes orange also, you might have seen. But it is found in yellow, green or white also. It is also this beta carotene or this lycopene. Lycopene is also found in tomatoes and responsible for their red color. Why tomato is red color? That region is same region, lycopene. Due to the presence of lycopene pigment, tomato is also red in color. Now, lycopene is a natural compound. Now, a question arises, that region I told you, that region for this red color, pink color, orange color, yellow color and carrot's color, orange color, for that beta carotene or lycopene. Lycopene is actually this carotenoid pigment like beta carotene, and due to that they have this type of color, red, pink, orange, yellow. Then now question arises, why lycopene is colored? That I will also tell. Why lycopene, it is actually pigment, but why lycopene pigment is colored, scientific reason I will tell you. Then lycopene is a natural compound found in watermelon and other fruits and vegetables that has antioxidant properties. Here lycopene, very very important properties is antioxidant properties. We require actually antioxidant. Means if you will use regularly antioxidant, then you will not become old so quickly. Okay, antioxidant will not allow to become you old. You will not age will be there, but you will not look like old. That is the characteristics of antioxidant. It will not allow to oxidize your body organs quickly. That's why name has been given antioxidant. Then now, one more things I want to tell you. Artificial color in watermelon. Sometimes you know that many people are there, they will cheat you. They will cheat you. If it suppose it is not of natural red or pink color of a watermelon natural, just to sell it, they will mix some artificial color in watermelon so that it will look attractive color like red, pink, orange. Then what is that color? Artificial color in watermelon. What is that? Then one of the most toxic dyes used in watermelon is erythrocyan. This is actually toxic dyes. This is a pink dye. Its color is pink. This is a pink dye and is mostly used in food coloring. You might have seen many times this food will be in pink color. In that pink color, that this chemicals only it is used. Erythrocyan. It is a toxic dyes. Sometimes in watermelon, they just seller will mix it just to sell it. Now, next question is why lycopene pigment is colored? Then this is somewhat scientific. If you have interest, then you can understand it. The red color of lycopene is mainly due to many conjugated carbon-carbon double bond, and as it absorbs more visible spectrum compared to the other carotene. Actually, in all you can say all fruits, and even in our food material like rice, wheat, vegetables, everywhere carbon is there. Many carbon will be there. Sugar means glucose, fructose, maltose, everywhere carbon is there. We are eating carbon in indirect way. In coal also carbon is there. Wood also carbon is there. Everywhere carbon is there. We are taking carbon. We are eating carbon in different form. It will not look black like a coal, but actually we are eating in indirect way. Then in what actually many details are there for that, but now I am restricting only for watermelon. Then in watermelon also carbon is found. Many carbons are there. Then carbon, all carbons are joined by each other. Sometimes may join by single bond, sometimes double bond, sometimes triple bond. Then if number of bonds are more, then number of bonds are more, then carbon bond will be strong. Correct? If less number of carbon bond is there, then that will be weak. Bond will be weak. More the bond, more the strongness. Carbon bond, if it is single bond, then it will be weak. If it is double bond, then strong. Triple bond, then further strong. Then here in watermelon, this red color of lycopene is mainly due to the many conjugated carbon double bonds. So carbon double bond, after that single bond, again double bond because many carbons are there. Then double bond, and then single bond, then double bond, again single bond. Like that way, double bond, single bond, like that way it will continue. That is called conjugated. carbon-carbon double bond, again carbon-carbon single bond, again carbon-carbon double bond, again carbon-carbon single bond. That is called conjugated carbon-carbon double bonds. And what is the benefit of that? What it will do? Conjugated double bond, alternate double and single bond. Then this double bond means conjugated carbon-carbon double bond, it absorbs more visible spectrum. Spectrum means light, more visible. Actually, many radiations are there. Then one radiation, common radiation is visible light. What we see daily, that light is coming under visible spectrum. Visible spectrum, we know there are 7 colors. Light has 7 colors, we know. Then I am talking about that colors. That is called visible spectrum. Spectrum means here light. Then these carbon-carbon double bonds present in watermelon, also called conjugated carbon-carbon double bonds. It absorbs more visible spectrum. It absorbs light, more visible spectrum compared to the other carotene. Many carotenes are there. Then this beta carotene or lycopene, you can tell lycopene is a carotenoid, means carotene. Then here in this watermelon, they will absorb more visible spectrum compared to the other carotene. Lycopene contains 7 double bonds. 7. It means it will absorb more visual light, more visual spectrum, which can be this lycopene, which I told in a watermelon, 7 double bonds are there, which can be isomerized. Means this chemical formula will be same. Chemical formula will be the same, but structure will be different. That is called isomerization. Correct? Then lycopene contains 7 double bonds, which can be isomerized to monocis, CIS, monocis or polycis isomers. Lycopene is carotenoid hydrocarbons called carotene. Simple way it is called, lycopene is called carotene. The extended conjugated double bond system of these compounds is an important feature in the carotenoids, responsible for their attractive colors, because it forms the light absorbing chromophore. Again, important point is that it forms chromophore. That is, that chromophore actually it absorbs the light. Carotene is responsible for their attractive colors because it forms the light absorbing chromophore. What is actually chromophore? Then example I am telling you, a special group, just like an NO group, nitrogen oxygen double bond. One group is there, NO group. Other is carbon-carbon double bond. That is the ethine group. Other example is hexine, one hexine group. Ethanol group means CO group. Nitromethane group. Then these are, if these are attached to the carotene or in any molecules, in any organic compound, if these are present, then it will absorb some light and it will look colorful. Here, this first I will tell some common examples of chromophore. Already I told ethine, hexine, ethanol, nitromethane means carbon-carbon double bond, carbon-carbon triple bond, carbon-oxygen double bond, nitrogen-oxygen double bond. These are the example of chromophore. One common examples include retina that is found in our eye. Common examples include retinal used in used in the eye to detect light. Due to this, retinal we detect light. Other examples I am telling you, various food coloring, fabric dyes. There actually azo compound will be there, nitrogen compound will be there, N triple bond. Fabric dyes, pH indicator, lycopene, beta carotene, and anthocyanin. Correct? These are the examples of chromophore. Various factors in a chromophore structure go into the determining at what wavelength region in a spectrum the chromophore will absorb. Other factors are there, many factors, various factors in a chromophore structure go into determining at what wavelength region. What there is a wavelength region. Okay, then at what wavelength region in a spectrum the chromophore will absorb. Then example I am telling you, carbon double bond. If ethine group is there, means chromophore is a ethine. All are chromophore. Carbon double bond, ethine is chromophore. Carbon triple bond, one hexine, that is also chromophore. Carbon oxygen double bond, that is also chromophore, means ethanol. And nitrogen oxygen double bond, that is nitromethane, that is also chromophore. But they will have these chromophore are different, and they will absorb in different wavelength. Then here ethine means carbon double bond will absorb wavelength, that is called lambda max. Max means maximum, lambda, that is a wavelength. Wavelength is their unit, we are measuring it in lambda, that is called lambda max. How much its length is there, that is measured in lambda max. Then its value is, for carbon double bond, its value is 171 nanometer. For carbon triple bond, it will absorb at 180 nanometer. And carbon oxygen double bond means ethanol, it will absorb 298, between 298 and 180, between that range. And if nitrogen oxygen is there double bond, then 275, between 275 to 200. What is actually this wavelength? What is meaning? What I told you, then that you understand. If wavelength is more, then it will absorb less energy. More the wavelength, less the energy, just in a reverse way. Then 171 means its wavelength is less. It means energy is more. 180, its wavelength is again little more. 171 is ethine, double bond. And carbon triple bond, 180. Then its wavelength is little more. Then more the wavelength, less the energy. Means, and every wavelength, here very important point, every wavelength is associated with some color. Every wavelength is associated with some color. That's why there is a range that between this, as for example I told you, between 180 to 290, in that range they can absorb, then they will give one particular type of color. If suppose it is 275 to 200, then it means it will give another type of color. Color depends upon wavelength, and its complementary color you will find. What color it will absorb, its complementary color you will absorb, not the same color. Because when light comes, then material will absorb, and then what they have not, little they will absorb, then what remaining, it will come out. Then what are the wavelength of the remaining? remaining light, that color you will absorb. I told you every color has own, every wavelength has own color. That's why what they will absorb, that color you will not see what is coming out, because some light will be absorbed, some will come out. Then what is coming out, that color you will absorb. That is called complementary color. Then that is the meaning of lambda max, wavelength. Then here I told you carbon-carbon double bond, it will absorb at 171. Carbon-carbon triple bond, that is called hexane, it will absorb at 180, more wavelength. Carbon oxygen double bond, further it is less, means 290, 180, between 180 to 290, further less. Wavelength is more, means energy will be less. Okay. And in nitrogen oxygen double bond, it is between 200 to 275. Again wavelength is more, means energy will be less. Reverse way, you remember, reverse way. And only here again I want to tell you, energy, sometimes word frequency is used. Then frequency and energy both are directly related, and frequency and wavelength is inversely related, reverse way. Okay, in any way color will be the same. You can tell either in the term of frequency or in term of wavelength, but you are telling for the same color. Okay, either you tell value of any things, either you can tell in dollars or in rupees or in any other currency. Correct? Like that way, here you can tell either in the term of wavelength or frequency, but you are telling about the same color. Then this I have told you about the chromophore. These are the chromophore. But here, to create the color in fruits or in compound, organic compound, one more you can say group is responsible, that is called oxochrome, a special type of chrome, oxochrome. It will again you can say a developed color. It will support in developing the color. Just by one example I want to clear it. Suppose benzene ring, benzene only C6H6, it has no color, no special color. But if NO2 group is attached in benzene, then it is called nitrobenzene. NO2, when it is attached to benzene, it is called nitrobenzene. Then now its color became pale yellow. Benzene was no color. But now if NO2 group attached, now it became pale yellow. Then here NO2 group is called chromophore. Now further I told about the oxochrome. Now suppose only in this nitrobenzene extra OH group is attached. Extra OH group is attached at para position. Actually in benzene ring 3 positions are there: ortho, meta, para. Okay, with respect to each other we are telling, with respect to some group we are telling ortho, meta and para. Then here when suppose at para position OH group is attached, then now same compound, what was the nitrobenzene, now it is called, when OH group is attached, then it will be called para hydroxy nitrobenzene. OH group is called hydroxy OH. Then now compound will be known as para hydroxy nitrobenzene, and now its color will be deep yellow color. That was pale yellow, now it became deep yellow color. Then this OH group is called oxochrome. Then these things are found in organic compounds. Then whatever we get the different color, you can say fruits, maybe carotene, any colored fruits. Watermelon I told you, correct? Like that way, any colored fruits, in that these are found. That's why they will give different type of color, because they will absorb the light at a different wavelength. That's why they will give different color. Now this I told you about this glycemic index. Then here less than 55, I told you it is low. So what is the example of food which is less than 55? Then soya product, bean, fruit, milk, pasta, grainy bread, oats, and lentils. They have a GI index, means glycemic index, GI index is less than 55, means low glucose you can tell, and 55 to 70, that is the medium. It's example food, whatever food coming under that. Then orange juice, honey, basmati rice, and whole meal bread. Whole meal bread, all are coming under 55 to 70. Correct? Again I am telling you, whole meal bread, orange juice, honey, basmati rice. These are the examples of you can say foods which coming under medium 55 to 70, and more than 70, that is called high level sucrose, a high level glucose. GI is high, more. That example is potatoes, white bread, and short grain rice. Okay, remember, short grain rice, potatoes, white bread, they have GI index more than 70, means you will find more glucose, high level sugar, blood sugar. If anybody will take, then blood level, sugar level will increase, glucose level will increase. Now I am stopping only here. Thank you.